Dear friends, welcome to my video. Kindly click on the CC button for subtitles. The term quantum finds its origin in the Latin word quantus, meaning how much. It has been ingrained into modern science through the quantum theory or quantum mechanics, one of the most revolutionary scientific theories of the 20th century. At its essence, quantum refers to the smallest possible discrete unit of any physical property, such as energy or matter. The journey towards understanding quantum started with Max Planck, a German theoretical physicist. In 1900, while attempting to explain black body radiation, Planck proposed that energy is quantized. This suggested that instead of being continuous, energy exists in distinct chunks, which he called quanta. In the quantum realm, energy could no longer be smoothly transitioned but instead jumped between these discrete levels. The idea of quantization was an innovative leap from the continuous, gradient-style transformations proposed by classical physics. The principle fundamentally altered our understanding of physical reality. However, the quantum revolution didn't stop there. 5 years later, in 1905, Albert Einstein took Planck's theory a step further. While examining the photoelectric effect, Einstein proposed that light could also exist as a stream of particles, or quanta of light. These were later named photons. With this, Einstein suggested the dual nature of light. It could act as both a wave and a particle, thus reinforcing the notion of quantization and extending it to light. The framework of quantum mechanics started taking shape as scientists delved deeper into the wave-particle duality of particles. Louis de Broglie proposed in 1924 that not only light but also matter exhibited dual characteristics. For instance, electrons and other particles could display wave-like behaviors. This notion added a new layer of complexity to our understanding of the quantum world. Quantum mechanics, therefore, is a branch of physics that seeks to explain the behaviors of particles at the atomic and subatomic levels. The theory encompasses several principles that defy our everyday intuition. The superposition principle, for instance, asserts that a quantum system can exist in multiple states or places simultaneously. This principle is strikingly displayed in the famous thought experiment known as Schrödinger's cat, where a cat in a box could be both alive and dead until observed. Another intriguing principle is quantum entanglement, where two or more particles become interconnected. Any change in the state of one particle instantaneously affects the state of the other, regardless of the distance separating them. Quantum mechanics has provided the foundation for many modern technologies such as lasers, semiconductors, and even the computer chips used in our laptops and smartphones. As we continue to unravel the quantum world's mysteries, we are paving the way for technologies like quantum computing and quantum cryptography, which promise to revolutionize information processing and security. In conclusion, the term quantum represents the fundamental notion that energy and matter exist in discrete, indivisible units. This concept has not only reshaped our understanding of the physical world but has also catalyzed significant scientific and technological advancements. Despite its perplexing nature and the paradoxes it often presents, the quantum world continues to be a fascinating field of study, pushing the boundaries of our knowledge and challenging our perception of reality. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.